Hello everyone. See, I took trigonometric practice set 6.1. In that, in first video, I have uploaded question number 1 to 5. And second video, I have uploaded question number 6, 5 examples. See why it is done like that, because this proof are new to you. And immediately to solve and do practice of it is not so easy. So what you should do, you require little practice for it, because this topic is totally new for your class and for you also. So what I feel, you need to do little practice, and what I suggested that you have to remember it. Okay, one thing is what you must know all trigonometric identities. Secondly, you must know the trigonometric ratios. When you all these things you will know, it will be easy for you to solve the examples. Okay, now question number 6 prove that 5 examples over. Now I am going to take the 6th example in this video. 6th onwards we will see the examples. Okay, so question number 6 is, from question number 6, prove that 6th question, that is 1 upon sec theta minus tan theta is equal to 1 upon sec theta minus tan theta is equal to sec theta plus tan theta. Okay, to solve this means, now see, this is LHS side and this is RHS side. Now taking LHS side, we must get RHS side. So for this, what you should do it, first 3 identities I will write here. See what, sin square theta plus cos square theta is equal to 1. Next is 1 plus cot square theta is equal to cosec square theta, and third one is 1 plus tan square theta is equal to sec square theta. See, these 3 identities you must know thoroughly. Okay, now see further now how to solve this example. Now what you have to do it, here we have 1 upon sec theta minus tan theta. So what you should do it, you divide and multiply this LHS by sec theta plus tan theta. Now see what happens. Now LHS side we took 1 upon LHS 1 upon sec theta minus tan theta. What we should do it, multiply by sec theta plus tan theta, and also divided by sec theta plus tan theta. Okay, so after doing this, what happens? See, now after doing dividing and multiplying by sec theta minus tan theta, we have got in the numerator sec theta plus tan theta. Okay, so what we have got, sec theta plus tan theta. Now next what you should do it, in the denominator we have got, see, this is a minus b and this is a plus b. Means a minus b and a plus b is what, a minus b and a plus b, which is equal to a square minus b square. Okay, a minus b and a minus b into a plus b is a square minus b square. Now we will substitute in this, that is what, a square minus b square, means it will be sec square theta minus tan square theta, and we know the identity. See, from this sec square theta minus tan square theta will be equal to what, 1. So we have got this sec theta plus tan theta. Therefore LHS is equal to RHS. Okay, so see, this is what, here sec square theta minus tan square theta is equal to 1. Now why this it is? Due to the identity. Okay, so what you have to do it, see once again. First in this example what you should do it, this you have to multiply and divide it by sec theta plus tan theta. Okay, so after dividing by this what we have got, sec theta plus tan theta upon sec square theta minus tan square theta, and this is identity, this is 1. So LHS equal to RHS we have got. Now this you have to write in the notebook. Now next example we will see. See, next example is now next 7th example we will see. 7th example is, see in the textbook it is given wrong. Now actual the 7th question is sin raised to 4 theta minus cos raised to 4 theta. Okay, which is equal to 1 minus 2 cos square theta. See in textbook the question is given wrong. Actually the question is sin raised to 4 theta minus cos raised to 4 theta. Now see, this we can write what, a square minus b square. How we can write this? Sin raised to 4 we can write in this way. Okay, minus cos raised to 2. Okay, this what, LHS. Now by LHS side taking we have to derive RHS side. Now see, we have written this what, sin raised to 4 theta we have written in terms of sin square theta raised to 2 minus cos square theta raised to 2. So in this we have got a square minus b square. Now we know a square minus b square is a plus b into a minus b. So we will write this in same manner, means sin square theta plus cos square theta into sin square theta minus cos square theta. Okay, now see, this is the identity. This is what, sin square theta plus cos square theta, which is equal to 1. This is 1. And this what, sin square theta minus cos square theta. But here what we want, 1 minus 2 cos square theta. So write this sin square in terms of cos square. So how we will write this in terms of cos square? Sin square theta means 1 minus cos square theta. And this minus cos square theta will be as it is. Okay, this what, sin square theta minus cos square theta plus cos square theta, which is equal to 1. So therefore this is 1. Now next see. Now here 1 minus cos square theta and minus cos square theta means what? 2 cos square theta. Okay, see, within 2 steps we have got the answer. This is because of the identity. If you know the identities thoroughly, it will be easy for you to solve the examples. Okay, now so here LHS it will be equal to RHS. Okay, now next example we will see 8th example. Now 8th example is what, same. Eighth example, sec theta plus tan theta. Sec theta plus tan theta is equal to cos theta upon 1 minus sin theta. Okay, 1 minus sin theta. Now here what you should do it, we LHS side, is in terms of sec and tan. But RHS side is in terms of cos and sin. So what we should do it? Write this in terms of cos and sin. Means you know, see what? LHS. Now sec means what? 1 upon cos theta. Okay. And tan theta means what? In terms of sin and cos. Sin theta upon cos theta. Okay. Now we have got this. Now what we will do it? The denominators are same. So what we will do it? 1 plus sin theta upon cos theta. Okay. Now what we will do it next step? Multiply and divide by 1 plus sin theta. Means what it will be? See, 1 plus sin theta upon cos theta into 1 minus sin theta upon 1 minus sin theta. Means now what? See, this what again? It is a plus b into a minus b. Means what it will be? A square minus b square. Okay, so what we will write this? See, 1 minus sin square theta upon cos theta and into 1 minus sin theta. Now see, 1 minus sin square theta means here that is cos square theta. Okay, so cos square theta upon cos theta and into 1 minus sin theta. Now see, here 2 cos square theta and here 1 means it will get cancelled. So here remain what? Cos theta upon 1 minus sin theta. See, did we got the answer RHS side? Yes. So therefore LHS is equal to RHS. See, in this way you have to solve the examples. Now next example, see, in next example what you should do it? Next example is 9th example. Okay, so what it is? If tan theta, it is what? If tan theta plus 1 upon tan theta is equal to 2, then show that tan square theta plus 1 upon tan square theta is equal to 2. This you have to show. Now see, here we have tan theta and 1 upon tan theta. But here what we have, which we have to show, that is tan square theta plus 1 upon tan square theta. So what we will do it? We will take LHS side and squaring both sides. Tan theta plus 1 upon tan theta, which is equal to 2. Squaring both sides. Squaring both sides. So what it will be? Tan theta plus 1 upon tan theta is equal to 2 square. So it will be tan square theta plus 2 times tan theta into 1 upon tan theta plus tan square theta is equal to 4. This is what? A plus b whole bracket square. Means a square plus 2a into b. b is 1 upon tan. So it is 2 times a into b plus b square. This all proofs are based on the identities. If you know the identities properly, it will be easy for you to solve the examples. Now see here, this tan will get cancelled. Remain what? See here, this is 1 upon tan square theta. Here it is 1 upon tan square theta. Okay, this tan will get cancelled. Remain what? See, tan square theta plus 1 upon tan square theta plus 2. So it will be, therefore, tan square theta plus 1 upon tan square theta is equal to 4 minus 2. So therefore tan square theta plus 1 upon tan square theta, which is equal to 2. Therefore LHS is equal to RHS. Okay, so this we have solved the 9th example also. Now see 10th example. If you see the 10th example, you will find that it is very difficult. But no, that is how much big the example it looks, that much easy it is. Okay, so let's see how after this 10th example we will see how to solve. It is tan A upon 1 plus tan square A raised to 2. Okay, plus cot A upon 1 plus cot square A raised to 2. See, this all you have to solve based on identity. See how big it is, look. But I have solved this example in the easiest way. See, nowhere you will get this. Here only I am showing. This is the easiest method I am showing. So you better pay attention here and see. So see here, this is identity. This is what? 1 plus tan square means sec square. So LHS, tan A upon sec square A raised to 2, plus here cot A upon 1 plus cot square means cosec square A. Okay, now see, now next one, raised to 2 again it is. Okay, now here you know, see, 1 upon sec means what? That is cos. So what you will do it here? Tan A into cos square A raised to 2 plus cot A into 1 upon cosec square A means sin square A and raised to 2. Okay, now see, this we will write in terms of sin and cos, this also. So it will be what? Sin A upon cos A, and this cos square A raised to 2 plus cot A, sorry, this cot, no, cos. It is cos A upon sin A into sin square A raised to 2. See, from this one cos A it will get cancelled, from here one sin it will get cancelled. So remain what here? Sin A into cos cube A plus cos A into sin cube A. Now see here, cos sin cos, here also sin cos. So what you can do it? You can take cos and sin common from this. If you remove cos and sin common, what remains? See, sin A into cos A. So what remains in the bracket? Here one cos we have removed out of 3. So here remain cos square A plus here cos and sin, from here 3 sines, 1 sin here removed out, cos it is out only. So it is sin square A. Okay, so see what? Here sin A into cos A into 1. So we have got this RHS. Here RHS is what? is equal to sin A into cos A. Therefore, LHS is equal to RHS. See, within 2-3 steps we have derived this. Here, this I did not write RHS here. So that I have written here. Now see, we got this RHS side. Here sin A into cos A. And this into 1, then that will be 1 only. So this we have got the answer. So therefore LHS is equal to RHS. Okay. Now next example which we will see, that is 11th example. Eleventh example is sec raised to 4a into 1 minus sin raised to 4a minus 2 tan square a, which is equal to 1. Now see, this is LHS side and RHS what we are going to get, that is 1 we have to get. Now see how to solve. So what we should do it, multiply this inside the bracket. So what we will get, LHS is equal to sec raised to 4a minus sec raised to 4a into sin raised to 4a. Okay, minus 2 tan square a. Now see what you can do it. Right, here it is sin, here it is sec. So no relation. So write in terms of cos. So it will be what? Sec square, it is, keep as it is, sec raised to 4a minus 1 upon cos raised to 4a into sin raised to 4a minus 2 tan square a. Okay. Now see, sin raised to 4a upon cos raised to 4a means what? Sin upon cos is tan. So this is what? Sec raised to 4a minus tan raised to 4a minus 2 tan square a. Okay. Now see here, this also we can write in terms of what? A plus b into a minus b, a square. So how we can write? Sec square a raised to 2 minus tan square raised to 2 means it is a square minus b square. So right now here, sec square a minus tan square a and sec square a plus tan square a minus 2 tan square a. Now see, sec square a minus tan square a is sec square theta minus tan square theta, which will be equal to 1. So this is what? 1 into, see, sec square theta, here 1 tan square theta and 2 tan square theta. So it will be what? Sec square a plus tan square a minus 2 tan square a. So it will be equal to what? 1 sec square a minus tan square a. See, from this 2, 1 we will subtract. So remain what? Minus 2 minus tan square a. Means we got sec square a minus tan square a. Again it is 1 into 1. Therefore LHS is equal to RHS. See, you have got. So such a big example and the answer which we have got is 1. Okay, now the last example from this exercise, and that is also very easy. See how to solve it. Now 12th example is what? Tan theta upon sec theta minus 1 is equal to tan theta plus sec theta is plus 1, and here in the denominator is tan theta plus sec theta minus 1. Okay, now see, LHS side we have to take and we have to derive the RHS side. So in this little change it is, we have to get this and this by using the identity. So you have to use the identity. See, 1 plus tan square theta is equal to sec square theta. Okay, so next what we can do it for this, we will tan square theta is equal to sec square theta minus 1. Here we have tan theta, so I kept here tan square theta and I took sec square minus 1 other side. So see, this we can write tan theta into tan theta, and this we can write sec theta plus 1 and sec theta minus 1. Okay, plus and minus we can write. It is a square minus b square, means a plus b and a plus b and a minus b. Now see, we'll separate the denominators. Means see, tan theta upon, we will take here sec theta minus 1 is equal to, we have taken this to the denominator. This tan theta we kept here, sec theta plus 1 upon tan theta. Okay, see, we'll do cross multiplication, tan theta into tan theta, sec theta plus 1, sec theta minus 1. Now what? Theorem on equal ratio. Now you have studied this theorem on equal ratio in 9th standard. Theorem on equal ratio you have studied. So what we can do it? Add it both, tan theta plus sec theta plus 1 and this what? Sec theta minus 1 and plus tan theta. Did you got the answer now? See, I have got the answer here by theorem on equal ratios. What? Tan theta plus sec theta plus 1 upon tan theta plus sec theta minus 1. So we have got, therefore LHS is equal to RHS. Okay, so from this practice set 6.1, sixth question, all 12 examples I have covered in this lecture. Now what you have to do it is, all examples you have to write it in the notebook, and from problem set you have to try to solve the examples of proof, and that homework you have to send it on to my personal number. Okay, thank you.